Hello, in this video, let's do graphical analysis of externalities. Okay, so let's start out with a negative externality. So I've got this market and equilibrium price in an unregulated market is $8. Okay, I get that because it's where supply and demand cross. And we're going to produce a unit, our equilibrium quantity of 4. Okay, let's say that for every unit produced, there's a $3 environmental cost. Okay, so that externality is $3 at every quantity. Okay, so what we're going to do, or what that really means is, we'll do this in like purple and go on the supply curve. So when they produce 1 unit, instead of the internal costs are going to be 2, we're going to go up to get the environmental costs. So 1, 2, 3. So we got a point right there. Make that bigger. And then from 2 units, 1, 2, 3. And then from 3 units, 1, 2, 3. Okay. And all right, and you can see what we're going to do here. So we'll just draw a line here from 3, and it's going to have the same line there, except this one is going to be called, the marginal social cost. So marginal social cost, MSC, is going to be the marginal cost, or the supply, plus the externality. Okay, and so what I want to know is how big is the environmental impact of this. Okay, so it's like how much is the extra production in this market. So I'll put that black because in this case it's pollution. Okay, so we're actually going to be producing 4 units. The socially optimal is where the marginal social cost meets demand, so that's going to be right there, and I'll use the line tool here. So this would go down here. I'll move that over just a little bit and move it up because I'm working digital here. Okay, so this could be the area of this triangle here is the dead weight loss. Okay, it's like the extra production that's not being paid for by either the consumer of the product who's on the demand curve or the producer of the product. So that is the dead weight loss, and that can be calculated by calculating 1/2 base times height. Okay, and this one is not perfectly, I mean, it is linear, but we're not really perfect here, so we'd be going about the distance here. We're just under 3 and about 9 or 860. So the distance there, you just calculate that triangle. Okay. Now the other type is a positive externality. So let's say instead of a negative, there is some sort of extra benefits added to the economy around this market, and that's going to be also $3. Okay, so this is a positive externality. So what I'm going to do is now this time I'm going to add it to the demand curve because that's the buyers now. Okay, so in this market we got 4.5 there, and then 4.5 as the equilibrium price. So I'm going to add it to the buyers. Okay, so I'm going to start up here, and I'm just going to go down there in a linear fashion. The distance between the two is $3, and where do I get the $3 from? Like that comes from this right here. Okay, so what really the benefit to society, the socially optimal price, is 6, because this is where marginal social benefit equals our supply curve. Okay, but in a unregulated market or unsubsidized market, the market's just going to produce this because the people getting those benefits aren't part of the market. So they're going to be right there. So now this time our deadweight loss is going to be over here. Okay, so this is our deadweight loss here. Some good shading right there. All right. Okay. So that's our deadweight loss, our inefficiency in the market. And this one we can calculate. So it would just be how many extra, 1.5 units. So it'd be, so our deadweight loss would be 0.5 times 1.5, because that's the quantity change, and times 3, and that would give us 4.5, and then half of 4.5, 2.25. If I were to want to quantify that. So that's how to analyze that. Something to solve this whole thing is through excise taxes, or maybe property rights, maybe tradable pollution permits, something like that, some kind of subsidy, and there you go.